Here's how you search for moving objects in the WISE image service. When you first load the WISE image service, you're dropped into a position search. But in this case, you don't want that. You want to search by solar system object orbit. You need to start typing the name of the object that you want. Then you have to wait for it to get a NAIF ID, and then you need to pick that NAIF ID. Even if it's a famous object, even if there's only one object in that pull-down menu, you have to pick that object because everything under the hood is tied to the NAIF ID. If you leave the observation date blank, it will search for all of the available data. That can take a long time, but for this example, I'm going to go ahead and leave it blank. The return image size default is usually okay. At the moment, I'm going to leave the overlay catalog off. You then need to choose the image set that you want. The image sets it's giving you here correspond to those deliveries that have individual exposures included. Note that you can search all of them at once, but for purposes of this example, I'm just going to choose all sky. Search. Okay, it's come back. Now, the WISE images, remember, come back in image sets. The 4 yellow rows correspond to an image set. You can see that there are 4 bands. But because we're searching on a moving target, it's given us the view of objects here with all of the images that it has found. You can see that the right-hand side changes corresponding to what I'm choosing on the left-hand side. When I pick a row from an image set, the image that I've selected is highlighted, and then the associated images are outlined in a dashed line. If you just want to see the images from a given image set, you can click on that icon, but in this context, it makes more sense to see all of the images that are returned. It has also calculated the orbital path for Victoria for the time that I requested. You can see it here, and these are the frames that it found. If I go back to the list of data and I scroll through the frames in the image, it's highlighted in the list. Now, let's figure out how we can get the photometry. Honestly, if you go back to the search page, turning on the overlay catalog is probably the most efficient way to do it. Here's the catalog results that it found, and it's overlaid the catalog on the images here. Note that we asked it to search all sky, and the catalog that it searched is that from all sky. There's no object in this cyan square here because the object is here at this time. This cyan square corresponds to the location of the object at this time. This cyan square corresponds to the location of the object at that time. This cyan square corresponds to the location of the object at this time. In each case, the yellow crosshairs correspond to the location of this object at the time of that image. So in this fashion, you can go through and identify which photometry is taken from which image. Obviously, searching the catalogs from the search page is the most efficient way to do this, but there's other ways to do it too. If we go back to the results page, let's get the location of Victoria in this first frame. Let's turn on click lock. I'm going to click at the location of Victoria on the first frame and then copy that position to the clipboard. Then I'm going to go to catalogs and then make absolutely certain that I've picked the All Sky database and then the All Sky single exposure table, then put in the position that I just copied and ask it for 10 arc seconds. Search. Now it's come back with a tiny catalog, and we're going to have to zoom in order to see that tiny catalog. Let's change the color so that it's easier to see. There are those sources returned here. It is a bright source, and so the pipeline thinks it's found several different sources at this location. That may or may not be physically reasonable, but that's not really my point in this example. The point that I'm trying to make is that it's found those sources in individual frames at this location. But because Victoria is moving, some of those objects might be from a later time. So in order to do this kind of search, you have to figure out the right ascension and declination that makes sense for your target. Do these kinds of individual searches yourself as a function of time and location on the sky to find the source that you're interested in. But it might be easier if you have a source that was known about at the time of the data processing for the delivery. If you go to the Catalogs tab and instead of picking single exposure, go to the all sky known solar system object possible association list, because Victoria is a source that's been known about for quite some time. So we can go to that. It's still got the position from before. Instead of cone, let's do a polygon for the image search. It's found several moving objects, including multiple apparitions of Victoria. We can sort this so that all of the observations of Victoria are collected together and get the photometry that way. If you want to get all of the apparitions of Victoria from the known solar system object catalog, you can go through the catalog search tool, which is another video. But let me just emphasize something that tripped me up while I was preparing for this video. Of course, the time matters. When you go to the catalog search tool, because of course, if you're looking at all sky image, but NEOWISE single exposure data, Victoria is long gone from those frames. And of course, you won't find it. The interactive nature of the overlays of the catalog and the images really help with sorting out those kinds of issues to make sure that the apparition is tied correctly to the photometry that you're seeing. It really helps a lot with assessing whether or not you should believe what the pipelines are telling you.